Good evening, everyone. Welcome to the Sitara Seminar Series. Today with us, we have Dr. Parmeshwar Udmale. He is an affiliated faculty and research fellow at Asian Institute of Technology, Thailand. He has a PhD in integrated river basin management from ICRE University, Japan, with 5 years of postdoctoral research experience. His research interests include water, agriculture, society, disaster risk research, drought monitoring and impact assessment, agriculture, food security and food supply chains, water and rural livelihoods, and monitoring sustainable development goals at the local scale. By today, he has approximately 20 plus publications, out of which 17 are listed in the Scopus. During his doctoral studies, he has researched the socio-economic and environmental impacts of droughts at the catchment scale in the drought-prone areas of Maharashtra. His postdoctoral research was to understand how local or regional scale drought impacts on crop production propagate to national and international level. Besides his core research area, he has also worked as a team member of different projects undertaken in a range of research activities, from SATREP's project in Nepal to human environment security in Asia Pacific, Ring of Fire in Japan. On behalf of the Sitara family, I welcome you, sir. And now we can proceed towards the session. Over to you, sir.
Thank you. You can see my screen, right?
Yes, sir.
Yeah, okay. So I would like to thank you, HOD, Sitara, and all the faculty members here for the opportunity to present a seminar talk here with students and faculties, of course. So today's talk is mostly designed according to my core research interest, but this is the not only research I'm doing here, but the core research which I want to expand in future is only some glimpse or overview will be presented here. So that's why I decided to name this presentation as Towards Drought Resilient Societies, Drought Monitoring, Impact Assessment and Management from Local to National Scales. So this presentation is divided into three components. First is background and scope of drought research, then a case study from Upper Bhima Catchment, Maharashtra. Then these two parts will be easy to catch and understand for students, and there is no doubt about faculty to understand this one. But the third component here is defining national scale droughts in India is quite tricky to understand, and it takes a lot of time to explain also. So I hope this design of this presentation will give some understanding to all the audience here according to their level of expertise in this field. So first is background. What is drought? I think most of the residents from semi-arid area of India are familiar with drought situation. And of course, in Maharashtra, this is one of the big problem, droughts, frequent droughts. So drought, before going into impact of drought, it is very important to see the drought assessment, how to define drought, how to differentiate between drought and water scarcity. So generally, drought is defined as extended period of time during which average annual rainfall will be less than long-term average. So in general term, just rainfall deficit is defined as meteorological drought. But there is a confusion between water scarcity and drought. This table is very good explanation. I found this from secondary source, but of course I can differentiate between drought and water scarcity in one line, but visually this table is very comprehensive. Then that's why I'm bringing it here. So water scarcity is generally long-term water balance, and it is mainly driven by natural and human factors such as natural water supply in that availability in that area is less and water demand is more, then it will result in water scarcity. But it is different than drought situation. Some area can face water scarcity throughout the year, several years, but drought is some years or seasons with precipitation deficit and mostly resulted from natural causes or a decrease in rainfall driven by or triggered by a decrease in rainfall. And but water scarcity and drought mostly treated as a single like concept in most area. But before going into drought assessment, it's very important to get a difference between this water scarcity and drought. At the end of this slide, we can just say that water scarcity and drought, drought always results in water scarcity, but water scarcity does not mean drought. Okay, so this is the favorite slide used by most of the people who are working in droughts, how drought is evolving over time. Generally, triggering point for droughts is less precipitation or alternation in hydrological cycle here in the form of decrease in precipitation. And not only precipitation, but temperature and wind speeds also can play important role in decreased water availability for a particular season. And this kind of drought is mostly considered as triggering point, expressed as meteorological drought, and it is measured using standardized precipitation indices. So at this moment, please neglect these short forms here. These are the only drought indicators with particular categories. Meteorological drought final in second stage can be seen in the form of agricultural drought, in the form of soil moisture deficiency or plant water stress. And it is measured using soil moisture index or normalized vegetation index. The third type of drought is hydrological drought, which takes times to be visible and is expressed in the form of decreased surface water flow. And this all types of gradual increase over the scarcity of water can result into different socio-economic impacts. But recently there is a new trend of identifying different types of drought also. So just to mention here, there are groundwater droughts, socio-economic droughts, and snow drought also. Recently there is Nature publication which is focusing on snow drought. So this is like a very like there are numerous definitions of drought and types of drought, various indicators of drought. But all this drought research revolves around this conceptual framework here, which is my favorite, and I wish to continue my research in this. That's why I'm as a like for student, it will be very important to get the overview of overall drought research, scope of drought research. It is made up of scientific research part, which is like historical and assessment of droughts, near real-time monitoring of droughts, and future prediction of droughts as well. And the second part comes under impact assessment, monitoring, and if possible, then projections of impact. The another subcomponent of this scientific research, which I want to give emphasize, is stakeholders' engagement in research. So this research will be primarily focusing on a local scale or state or national scale, but stakeholders from local scales can be involved into the scientific research also. This is called as transdisciplinary research. And it is very like a well-known field, evolving a field where people are focusing on co-design and co-producing the scientific knowledge. So this scientific research with stakeholders engagement can give us some practical policy options for increasing the drought resilience in the form of preparedness, response strategies, and so on. That will be like evidence-based justification for selection of policy options for overall drought management from local to national scale. Okay, so this is just simple background of drought, definition, types, and what is the scope of drought research. The next part is I have made it very simplified, but maybe I'm not sure whether people can stop me and ask some clarification in between, but I will try to make it more simplified here. This presentation, second part here, will be focusing on one case study which I did during my PhD using secondary data and primary data itself, going into field, interviewing farmers, focus group discussion, collecting water sample for water quality analysis, and so on. And this all results are published in 3 journals mostly based on PhD, and some pending task is also there, which will be coming. But I will be using some brief summary of these papers to explain the different assessment approaches of drought, then impacts, and what are the mitigation strategies, particularly for one case study area. But before going into case study detail, we need to know why it is important to assess the drought impacts. Generally, drought itself is very difficult to understand. There are many confusions over definition of droughts, when to declare drought, and then it makes it more complex to assess the drought impacts. So, to understand the complex impacts of drought, it is important to look into the different sectors affected by drought. The second is, after knowing the most or worst affected area, it is evidence to direct the drought relief measures in that area. Also, the impact assessment could be used for determination of drought proofing activity area, where we can do some actual development or implementation of drought proofing activities. Also, impact assessment studies can provide us some proactive drought risk management alternatives. Then different vulnerability factors at household level or vulnerable regions such as sub-districts or districts. Mostly, I think because of data limitation, we cannot go until the village level, but that is also possible to do a vulnerability mapping through this drought impact assessment. And finally, the final benefit of this drought impact assessment is we will be having evidence to justify where to divert mitigation actions, where to design location-specific mitigation strategies, such kind of thing. So for this purpose, I have chosen this Upper Bhima Catchment located in Marathwada and Western Maharashtra region here. Yellow color here, you can see. Those who are not familiar with the study area is shown here. It is particularly a drought prone catchment, how we will be looking into next slides also. But the initial information about study area is, it is about 46,000 square kilometer, and then more than 70% land area is used for agriculture purpose. More than 80% of the rural population of this Upper Bhima catchment is dependent on agriculture related activities. 42% cultivators and about same percentage laborers, unskilled laborers in agriculture. And this region here is falling into semi-arid category here in agroecological zones of India. So water scarcity is there, but drought makes it even more worse. Generally, to assess the drought situation, people use different drought indicators. And not to confuse with this figure, I will be explaining how to read this chart also for those who are not aware of the drought indicators. There are more than 30, there are more than 4 types of droughts and more than 30 types of drought indicators. And it's really confusing which indicators to choose for what purpose. So to understand the meteorological drought situation, most commonly used drought indicators are standardized precipitation index and standardized precipitation evapotranspiration index. For example, here this graph here shows standardized precipitation index. This graph is easy to read. Here is the index, standardized index, ranging from 0 to 2 in this blue part here, and minus is deficient rainfall. So just no need to understand this graph completely, but just focus on this red part here. This means standard deviation from the normal rainfall. So particularly for year 2002, 3 and 2012, we can see here red part means extremely dry drought here. So a red part here shows drought situation in the catchment, and blue part here shows excess rainfall in the catchment. And I think those who don't know the indicators, no need to scratch their head, just focus on the situation here. Red part here in past 6 decades of data availability, 1951 to 2012, because that study was concluded in 2015. So we can see from this simple drought indicator, what is the rainfall deviation, decreased deficit rainfall or excess rainfall over the 6 decades. And we can clearly notice the drought of 1971-72, and then drought of 2002-2003, which I experienced during my school days, and the drought of 2012-13 here. So this drought situation was there in Maharashtra state and mostly in Upper Bhima Catchment, which is the study area. So we know the drought situation here. We will be looking into the drought situation in terms of surface water, then groundwater also, and different impacts. But before going into that also, little bit theoretical part here, how to obtain the standardized drought indicators. This is example of standardized precipitation index estimation here. A little bit statistical knowledge is essential to understand this conversion from precipitation to standardized scores. So what happens generally for meteorological drought, SPI, most commonly used, precipitation data is fitted to gamma distribution, which is the best fitting distribution, and that is converted to standard normal distribution here with mean 0 and variance 1. So that means like this is the absolute value. You can convert it into some standard normal scores here. Below 0 is deficient rain compared to normal average, long-term average, and above 0 value of SPI is excess rain compared to normal or long-term average rainfall. So this is a simplest graphical explanation we can expect here. When we are doing this analysis, there is only few lines of code stopped in this indicator, so no need to worry about this one, whether it is point location or whether it is global level analysis. Just one few simple lines can give us this conversion here. But I just wanted to highlight some theoretical part here also. And then standardized precipitation evapotranspiration index is the another widely used meteorological indicator, which uses temperature component also. So precipitation minus potential evapotranspiration estimated by different methods gives deficit, and then this deficit is fitted to gamma distribution and converted to standardized scores. And to do this, we can use GIS or Python. Mostly I use GIS and inbuilt window, ArcMap and Python window in that, or model builder to do the geospatial analysis. And these are the steps for doing this drought assessment. First, like very simple one for those who know, and those who are hearing this first time, a lot of things to learn there. First is to create shapefile or get it from secondary source or create boundary raster. Then try to match the grids, make the minimum possible unit. Then use different raster calculation techniques, extract data for particular area of interest, then obtain zonal statistics to know the situation there. This is simplest possible overview of the geospatial analysis. This example here shows the drought situation in Vietnam, which I'm doing. This is the current ongoing analysis, so I thought it will be easy to show. This is just example to know how this geospatial data looks and how it can be analyzed in GIS. This is one option, but there are numerous alternatives for this. For example, we can use MATLAB or R programming. The only need is to load your data into your computer and understand the matrices here. 3D matrices. This is like one map for 1 month. This is for second month, third month. So if you understand this one, there will be easy to process all the geospatial data. It will be very easy to process that one. And a lot of online tutorials are available for students to learn this from the scratch. Okay, so we know the drought situation. 2012 drought was the worst. The worst was 1971-72 drought in the catchment, then 2002, 2003, and the recent drought 2012 in this analysis was the worst one. And using these 6 decades of data, we can easily find out the durations of drought, average duration of drought in the catchment, and also inter-arrival time of drought, that is duration between 2 consecutive drought events on an average. So this is the outcome here. Average drought duration in the catchment is about 2 years. Catchment as a whole, I'm not talking about the particular sub-districts here. And inter-arrival time is about 3.5 years here. So once in 4 years or once in 3 years, the catchment somehow experiences meteorological drought. And This can be visible in the form of decreased light storage in the reservoirs. This map here shows the reservoir storage for the major administrative divisions of Maharashtra state. Sorry. Yeah, so our catchment is located into central Maharashtra and Marathwada region here. So we can see during May 2013, because of meteorological drought, it can be visible into surface water drought also, reservoir storage. And this is the specific example that drought has caused almost zero storage in the state reservoirs. In particular, these three. And it is also visible in the form of groundwater depletion here. So this map shows groundwater level below surface from November 2010 to May 2013. In these 3.5 years, about 4 to 5 meter average decline or in groundwater table observed in the Upper Bhima Catchment itself. So that is quite severe because of this 2012-13 drought year. And then after assessing the drought assessment, we will be looking into some generally observed drought impacts. And these are the results from the primary interviews, focus group discussions conducted in May 2013. The sample size was 223. Then we visited 23 villages spread across the catchment. We also collected the water quality sample. But generally observed, these socio-economic impacts were reported by the farmers are very obvious one. And I think these were the open-ended questions. So how farmers define drought is listed here. Most of the water resources dried, crop failed. They don't have fodder for their livestock. Their livestock, because of less water and fodder, their health is not good in good condition. But in addition to that, we also ask a close-ended question to them. And surprisingly here, loss of employment and reduction in household income was the mostly reported thing in the catchment. And that is very obvious because drought has significantly reduced the income from agriculture, and 80% of the population in the catchment is dependent on agriculture. So another important thing from this survey was these last 2 points here. Here we can see very high response on hopelessness and sense of loss. So farmers reported that they cause very high hopelessness and sense of loss because of drought. But they are like a response to this question. They strongly said that drought is not the one who is making farmers to cause suicide in the region. So this kind of socioeconomic.
What is the color code on this?
Sorry, it's not visible here. This is very high here, then high, medium, less, and very less. I'm sorry, it is not visible here. So
the lower part of your PPTs is getting cut out.
Okay, so yeah, that is the problem. I don't know why that is happening here. So this is the color code here.
Sorry, now it is there.
Yes. Okay, so I'm sorry for that technical error.
But you need to project it. So.
Okay, so then again it happens like that. But I will explain this color code. Very high and very less here. So blue and orange are very high responses. Loss of employment, reduction in household income, this kind of thing. So perceived impacts were quite severe. Yeah. The next part focuses on perceived severity of environmental impact. That is also very obvious here. Here it is visible here, very high to very less scale. But this is just to give students the glimpse. This is just to give the students to glimpse of the environmental impacts, socioeconomic and environmental impact. But when we try to quantify those impacts, this is also visual slide talking about drought impact on domestic water supply. This slide shows mostly women and children are engaged in collecting the water during drought years. I'm not sure what is the reason behind that, but that is again point of big discussion there. But one important thing we notice here is that groundwater sources were used for meeting the source of domestic water supply during drought year. And mostly tanker water supply was more than 50% respondents were using water supply from tankers during drought. Okay, this figure is simplest to understand. This is just histogram plotted here. These are households, number of households. This is the scale telling minutes spent per trip for water collection. And same this thing for drought year, minutes spent per trip for water collection and number of household. So if this is shifting upwards, that means water time spent for water collection during drought was more compared to normal year, of course, because of drought-driven water scarcity. Similarly, this is, I think, not significant here, but we can say because of drought, people were carrying huge vessels to carry water, and as much as water they can carry in one go, they were like going with that. So number of trips reduced during drought years. And these are the just variables to show, but there are several other variables we analyze for this study. Then while talking about the drought impact on crop production, which is very obvious, first photograph here shows one farmer destroying their wilted cotton crop due to monsoon failure in 2012, July. I'm sorry, some question is there or some problem? Okay, the second picture here shows the damage fruit garden in Ahmednagar district, and the date is not visible here, but it is taken in 2013. So on an average, in the catchment, major crops are very well known: pearl millet, maize, sorghum, wheat, chickpea, cotton, sugarcane, and onion. And on an average during this drought, about 86% reduction was reported in crop production. But farmers from more irrigated area were able to adapt to the drought condition for the first year, but we cannot comment on what was the situation of their crop production during the subsequent year of drought. We haven't analyzed that one. Then drought also has impact on rural employment. A number of people engaged in unskilled employment decrease because of drought. Normal year, this is the situation here. Many people, like 3 to 6 people per family, were engaged in unskilled employment, mostly in agriculture. But during drought, there were not many people having jobs here. So this is near zero, 1 to 0 here. Similarly, work days per week also decrease. So that this gives the information that during, of course, because of crop failure, because of water scarcity, crop failure, the employment opportunities went down and then decrease their income and cause indebtedness also. So this is the comparative histogram showing the income from agriculture and livestock during normal year and drought year. So if you have understood the first explanation of reading this chart, like this is the money in Indian rupees here, the number of households. These are the slots here, 0 to 200,000 Indian rupees. So most of the family's income is below 100,000 Indian rupees during drought. But during normal year, it can go until 600,000 Indian rupees per year. And also the amount of availing loan. So this is the income during a normal year here between like 0 to 600,000 Indian rupees. And the same thing, availing loan. That means farmers were having this much amount of loan on their account, and that is equal to 1 year's income. So we can imagine that if drought happens for 2 years or 3 years, so every year that loan amount will be increasing, that actual amount, without considering the interest. And in response to drought, okay, now we have 10 minutes more, so I should be hurrying. A different kind of preparedness and adaptation strategies were used by farmers. For example, mostly farmers were using storing crop for expected drought year, storing crop residues for livestock also, mostly, but not other adaptation strategies, preparedness strategies. And another important thing here was highlighted that this is like very high to high thing here. So most of the farmers' responses to adaptation strategies were like high to very high, except this changing traditional irrigation practices. So this study was conducted in 2012-13. So maybe situation now might be like might have changed there, but at that time this was the situation. Farmers were reluctant to change their traditional irrigation practices. Okay, and while talking about adaptation and mitigation measures, these are the widely noted mitigation measures or mitigation strategies adopted by government. So National Rural Employment Act, water supply tankers, cattle camps, fodder depots, compensation to agriculture damage, etc. And this slide here shows beneficiaries' level of satisfaction here. So those farmers, number of farmers who got benefited from these schemes, their level of satisfaction is here from very high to high scale here. So you can see most of the government mitigation strategies, farmers are not quite satisfied about that one, except cattle camps and fodder depots. Okay, so I'm going to skip these policy points to strengthen capacity to mitigate drought at micro level because of time constraint, but we can bring this up in our discussion point. The second complicated thing, I hope students understood the things I explained until this point, but this next part is quite statistical analysis and difficult to understand, but I will try to explain it in less than so can I check with the time, how much time I have?
You can take 5 more minutes to conclude.
Yes. So maybe 5 minutes, it will be difficult. 6, 7 minutes, I will try to do that. Pardon
This
me.
is Shah.
Yes.
I think, I don't know, Anand, can we just let it go for a little longer then? I mean, we have to be very strict about the half an hour.
Maybe another 5 to 10 minutes.
Okay, because my timer shows 5.5 minutes left. So maybe 10 minutes maximum.
Yeah, go ahead.
Okay, yeah. So for defining, this approach will be talking about defining national scale drought in India. So from previous talk, I explained that there have been a lot of drought indicators used by many different authors, more than 30 drought indicators widely used. But there is no generalized approach to define or use that indicators to define national scale drought. And there is a very well-known database, EM database for natural hazards, which records all the hazards, including drought, using this criteria here. 10 or more people are dead because of that particular hazard, or 10 or more people, 100 or more people affected. This is their criteria. But this criteria is quite subjective. So I was just wondering about how these nations declare drought or how they decide the drought threshold when they go for declaring the national scale calamity or emergency because of drought. So this example I found from the US study, they considered if more than 50% of US agricultural land is exposed to drought, then it is called as national level drought. But 50% is quite high. So I wanted to develop some generalized statistical approach to come up with this threshold. And then I tried to find out the definition used by India Meteorological Department about declaration of drought. They called a drought year or deficient year in India if monsoon rainfall for 4 months, June to September, is like having 10% deficient rainfall over 20 to 40% of country's area. And the second definition from them was about all India severe drought year, or now they call it as large deficient year, if the monsoon rainfall deficiency is more than 10% and covers more than 40% of country's area. So USA is saying more than 50% area exposed to drought is national. Then India is saying more than 40% of India's land is exposed to drought, then it is national scale. But I tried to do one statistical analysis, very simple terms, use drought indicator data, know the cropland area exposed to drought, this indicator here. Simply by using cropland data, drought indicator of choice, any drought indicator can fit here. You know the cropland area exposed to drought. Then second part is distribution fitting. You can neglect this part here at this moment, just to rank the drought years with highest area affected to lowest area affected. And then use superposed epoch analysis method with bootstrap. These are statistical terms which really takes time to understand. So I'm not going to talk in detail, but I will explain the superposed epoch analysis to find out the threshold for this statistical analysis. Very simple terms presented in more complicated way, I can say this. The two variables we want from here is cropland area exposed to drought and particular production for that particular year. These two variables we need only from this analysis. So this is superposed epoch analysis here. This makes it more clear here. Suppose we have 7 years production for this one window, we call superposed epoch analysis window. Then simply by comparing this 1965 production with previous 3 and previous post 3 years, we can say that, okay, there is some decrease in crop production here. Similarly, for another event, whether it is drought or not, we can also compare this year's production with this pre 3 years and post 3 years drought years. Production, and then by using average of these two, we can know that, okay, average production of this window, these two window, is less than this 6 years here, 3 years here, 3 years here, and then again average of this and this. So simple explanation in graphical format here. And so this is SEA to understand the decrease in crop production for a particular year. And this gives the information about India's time series of crop area, production, and yield here. This is area and production, and this is yield, tons per hectare here. So yield is increasing and production is also increasing because of many technological interventions. By using the framework, which I explained, that complicated thing, we just find out the area exposed to drought. This blue bar here shows area exposed, cropland area exposed to SPI3, meteorological drought. And then this pixel here shows cropland area exposed to this second indicator, SPEI3. And this red bars here shows the decrease in crop production for that particular year. So if we see, there is good correlation here. More area affected, decrease in crop production. More area affected, decrease in crop production, but not very clear. So by using this superposed epoch analysis and bootstrap, we obtain the decrease in crop production for 1 year, then top 2 years, then top 3 years, until 100 years or all years. And based on this, we found the changing point. This left-hand side shows the percent change in composite mean of crop production here. For example, topmost area affected year, 65 or 71. What is the decrease in crop production? 15%. In 2002, 15%, like this. So these are the more years for which decrease in crop production happened. This red line shows actual decrease in crop production. And then this gray bar here shows the bootstrap analysis, which is a statistical technique used to identify the significance level. So if this red line and this blue line here is like crossing here, above this blue line is non-significant decrease, and below this blue line is significant decrease. So we call this point as changing point, where all the years to the left of this point will be considered as composite drought years having composite significance decrease in crop production. So this is just for different indicators and threshold, but how it looks, the result, we identified these years here with most decrease and most area exposed to drought, and how results look here. This is the second last slide. So to just conclude here, these are the years arranged in ascending order. This highest area exposed to drought here, then lowest area exposed to drought. Then these pink bars here are decrease in crop production for that particular year. So by using this analysis statistical approach, all the years we found to the left of this are defined as national scale drought years in India. And from this analysis, we can be 99.5%, 50% sure that these are the drought which are showing significant decrease in national level crop production. And what is the related cropland area exposed to that composite drought years here? Here, 20%. So this is the threshold. If more than 20% of the India's cropland area is exposed to drought, then it could be considered as national scale drought. This is using one indicator, but second indicator is also giving the similar results. But the indicator drought years might be changing because of the indicator's ability to capture the drought situation. Okay, so based on this, we can say that if more than 20% of India's cropland area is exposed to drought, then we can consider it as national scale drought. And those drought can result, national level cereal production can decrease by 3 to 4%. But this study also has limitations, and maybe we can discuss if someone wants. So thank you very much. This was my presentation. I'm sorry, 3 minutes more I have taken for this.
Thank you, sir. Now we can take the questions. So you can raise your hand and I'll call you up.
Abhinav, sorry, I had to leave. So can I just ask a very small half a question and then
Yeah, sure, sir.
Yeah.
Sure, sir. Sure.
Dr. Udmale, like this, our Govarikar and company had this 16 parameter model to do monsoon prediction. So like that, this drought predictions, I mean, can we have a good probability in predicting? You said that, 2.5 year cycle or 3 year cycle or 4 year cycle. But your data was kind of a heuristics. But let's say for future, is it possible at all to sort of, with a good probability, we can predict droughts?
Yeah, that is a very difficult question to answer. There are quite a few studies published already on use of artificial intelligence or neural networks to predict the drought situation. So I think there is possible to predict the drought situation for next 2 or 3 months, but beyond that, it is very difficult. So that is one part of my component, like research scope also, but I haven't worked on that. So maybe cannot tell it in with very high confidence, but there are certain studies already published on prediction of drought or early warning of drought on monthly scale or weekly scale also.
Yeah, Dr. Udmale, I'll catch up with you tomorrow morning, 9:30 on one.
Okay. Okay. Thank you, sir. Yes.
Thank you.
Yes. Yes.
Thank you, sir. Any questions? You can raise your hand.
So maybe everyone understood everything.
Anand sir wants to ask a question. Anand sir, please.
Yes, please.
Yeah. I just wanted to clarify that may not be the case. As I understand, because of the climate change, there has been a lot of redistribution of rainfall. So whenever we call it like a normal monsoon year, so we may get close to whatever 90%, 100% of the rainfall. But the timing of the precipitation has shifted significantly, or we have very high or heavy rainfall events that during only few days we get most of the rain.
Yes.
So how is that situation captured whenever we are using this overall precipitation as an indicator for describing droughts? So I mean, I'm not from this field, but I just wanted to.
No, I think that is very experts question in drought field. Most of the experts in drought field, they ask this question. One of the limitation of using these drought indicators are mostly monthly scale analysis data is used for the analysis. So this temporal variability is not captured well, and still there are many ongoing debates on whether to use this standardized precipitation indices for daily basis or weekly basis, but most commonly accepted are monthly basis or at least for seasonal basis. So these drought indicators may not capture the temporal variability for daily basis, and that's why we cannot use it for like predicting future drought also using monthly time scale.
No, it's not only about predicting, but also about declaring drought or announcing drought.
Yes, yes. So for that purpose, I think more than one indicator. Here now I'm talking about only meteorological drought indicators, but hydrological drought or soil moisture drought or any other combined multivariate indicator could be used for this purpose.
Okay.
Does students have a question? Otherwise, I can go.
Yes, sir. So you can.
There's one question in the chat window. Abhinu, if you want to read that out, or NC, you can go ahead. But I just wanted to point out that there's one question in the chat window.
Yes, ma'am.
Yeah. One thing is about the pattern, like the 72, 2002, 2012. So 2022 may not be, So what is the kind of, how can you make this pattern? Somehow there should be some patterns should be available, isn't it? That's one question. Second is, as Anand was telling, the uncertainty is increasing, because of this extreme events, like when the number of rainy days are increasing and decreasing and the intensity is increasing. So I think, so we have to expect more drought. But my question is, about the drought proofing measures. What is that in your mind? Because there are different types of that, so what do you go for?
Okay. Yeah, the first question is about identifying the pattern. I think for this purpose, more finer scale data is important, and not only one drought indicator, but combination of many drought indicators. And also it should have some joint probability considering all the characteristics of all the drought indicator. So that complexity will bring some more generalized pattern in this case. But by looking at only one drought indicator, I think patterns are not possible to capture. The second question is about drought proofing activities. So the mostly drought proofing activity starts with the water management, agriculture water management. What we say, I forgot the exact word for that, but like water management practices, increasing the storage capacity of the reservoirs before the drought is happening or in anticipation of the drought. The second is like not only one storage facility or one big reservoirs, but a distributed reservoir system could strengthen the water availability in spatial scale, also increase the recharge. Then third point is coming about the small scale ponds, farm ponds, that is also burning issue in India. This kind of water storage or water management facilities can be adopted. The second thing is about on-farm water management practices, such as I mentioned in the qualitative analysis also, farmers' response, application of improved irrigation technologies, practices will be helpful. Mulching, changing in the soil preparation, or what we say, land preparation activities itself can help. The other last point is about what we say, improved agro advisory systems at the farm scale, or at least at the local village scale. That is also taking some time to improve in India, but some studies are already ongoing. So such kind of drought preparedness activities or mitigation strategies could be designed in advance. This is from larger areas to the farm level also. The
Because
other thing,
the World Bank,
Mhm.
they have a 2006 report where they tell that we are going to have more droughts now because of this glacier melt and all, and in the Himalayan rivers.
Mhm.
And then what we need is more and more dams. And then they compare the kind of storages in across per capita storages in India and US, and compare and see that we have to store more. And then the other extreme is when what you are talking about, the kind of more local management,
Approach.
like
Yes.
watershed management, and increasing soil moisture, and so
Mhm.
um, you say that all these are together needed. It's not a either or, it's a both and.
Yes. So
Okay.
my thinking is that location specific strategy, it's not like one solution fits all areas. So since the beginning of my research also, I'm thinking that how the drought research could be improved at local scale, and how this local scale mitigation measures can be improved. Not only this adaptation or preparedness activities, but some coordinated activities or well efficient implementation of drought mitigation activities which are designed by the governments are also important, and that plays major role in mitigating the. And so I think that governance part come here, and that governance part I'm very weak in that. I think drought governance related research here.
Okay. So thank you. I think we'll continue tomorrow. Thank you.
Yes, sir. Yes, sir. Thank you. Thank you.
Thank you, sir. Penin, sir.
Hi, Dr. Udmale.
Hello.
So, sorry, I couldn't pick up the slides because the numbers were not visible, slide numbers. So, can I ask you about your SPI and most of the slides you showed about SPI index and groundwater, etc. But I couldn't see the data that was used for it. Could you explain on the SPI data used, and why would it be a different drought causing on the ground? Because this is purely driven by an empirical formula, correct?
Mm-hmm, mm-hmm.
So why would I would argue that on the ground the drought scenario would be different? Would you say why would it be different, or why not it would be different? A drought classification on the ground and not by SPI?
Drought classification on ground in the form of what?
So
I'm not
what drives a
getting.
drought? What causes a drought? Because
Yeah.
as I see it here,
Yes. Mm-hmm.
it is purely driven by your rainfall pattern
Yes.
through the
Mm-hmm.
SPI index.
Mm-hmm.
But SPI has its limitations to use it on the ground, right?
Yes. Yes.
Do you know what they are actually for farmers? Why they can be used?
They can't use SPI for this drought monitoring, right?
Right.
Okay.
They cannot be for farmers for a
Yes,
specific reason.
yes, of course, yeah. So generally this, I'm using this one simplified indicators commonly used, as you pointed, is for identifying the events which could trigger the meteorological drought, and it starts with precipitation deficit mainly. And then it comes to the, and there was some question, I forgot who asked that one, but Professor Anand Rao asked that question about variability. So generally SPI is used for monthly scale and more, but if it fails to capture this variability within weeks or days, then it cannot be used for monitoring the drought. And standardized precipitation index is mostly here used to identify the meteorological drought which is triggering other kind of droughts. So in response to your question that why we cannot use standardized precipitation index as a drought indicator at farm level, because it may result in drought situation in the form of agriculture drought or hydrological drought. It is not guaranteed. So that kind of
Because all
yeah.
your why I'm saying this is because you've made this in your 2020 paper
Yes.
and linked it to farmer surveys where it is technically not correct to link this SPI drought to a farmer's drought, because farmer's drought is more a hydrological drought wherein a rainfall occurs, it then captures into a catchment, turns
Yeah.
into runoff, groundwater
Yes.
recharge. There's a lot
Yes.
of other things which happen.
Yes,
And one
yes.
more thing which is very specific about SPI is it does not take into consideration ET, because we had a paper with IMI on this,
Yes,
and we cannot
yes.
use this for farmers because ET, which is driven by farmer activities, cannot be used. So I was just needed some more clarity on that, but yeah, we can discuss that when we
Yes,
have
yes.
our time.
Yes, yes.
The other question was, you had an agro, I'm sorry, again, your slide number was not there. Can you go to your agroclimatic zone?
Okay.
You ecological, agroecological?
No, that is not my. No, that is not my slide.
I
It's
know.
from
But
second.
do you know the source of this and why they were classified like this?
Sorry, I can't explain that one because I just got it from secondary source.
Which source was it?
Shukla et al. Here.
No, I think it's a government. Normally, people cannot do this. Government has to do an agroclimatic zone.
Okay,
but anyway, so okay, can you go to your groundwater slide? Your maps for groundwater. The next one, I think.
Yeah.
Blue one, yeah. This is your paper, right? And
yes.
Could you tell me like how many? What was this data used?
Sorry.
What data was used for this?
Okay, so there was one governmental portal for this data. I downloaded from that, and after downloading that data,
which data?
Groundwater level. It was government data portal. I haven't put it source here, but it is from government website. I forgot the name because there are many.
So there are two agencies in Maharashtra that monitor
yes.
groundwater. One is the GDSA and the other one is the CGWB.
No,
how many
it should
wells
be from.
were there?
Yeah, it should be from Central Groundwater Board.
Okay, how many wells were there?
It's like for more than 36. I'm getting like one well for one sub-district.
Okay. So you said you're from Maharashtra and worked on farmers because farmer suicides, everything is a lot of connected to the groundwater for some reason. And the data that you say, Central Groundwater Board, is not reflecting the farmers' actual use of groundwater. Do you know why? Because you're tying this to farmers. That is my concern. If you just said groundwater, it's enough. But you're tying this to groundwater for farmers, it doesn't reflect it. Because a simple reason is the groundwater levels monitored by the government are shallow wells, wherein a farmer mostly uses, you're from Marathwada. Do you know the aquifer type in Marathwada?
No, I'm not expert in groundwater modeling.
So it's not modeling, just type. So
yes.
It's mostly hard rock aquifers, wherein your water does not get into the aquifer and there is a big lag time. Sometimes it's 1 to 2 years. Okay, so that is where my concern is when you say about SPI and meteorological droughts, that affects your farmers' groundwater data as per your survey. I'm finding it hard to understand because a farmer cannot see the groundwater within a year or two. It might be a very good rainfall year, but your groundwater level is very, very deep because there is a lag time of 1 to 2 years to reach the aquifer.
Yes.
It doesn't go like today it rains, tomorrow it doesn't go into my well. Right? So I'm not sure, like, I'm sorry to disturb that point, but all these analysis linking it to the survey, it's kind of a binary survey and is yes or no. Okay, there's no reasoning for the survey. You come to the farmers and say, like, why is your attitude like this? Do you think it's a drought or not? But at this point, it's good for a paper, to show these graphs. But then when I say it's binary, it's just yes or no, but not linking to the actual physical what is going on.
So
I want to caution that because here, Sitara, it's very important, that part. You have to link it and close the loop. And maybe that's why students are not asking questions. But yeah, I'll stop here.
Yeah, so I think you are right that these two parts are not linked here. The first part is assessing the drought is a separate one to know the drought situation only. So whether it is reflecting at a local scale in the form of agricultural drought or hydrological drought, this is not used in this or not verified in this analysis. Yeah.
Thank you, sir. We have two questions from the chat as well. So the first question is from Mahesh Parihar, and he says that, do you suggest any intervention for impact assessment based on this study? And do you suggest any intervention after impact assessment based on this study?
Impact assessment, that is like drought impact assessment, right?
Yeah. Yes.
So interventions for drought impact assessment, I'm not getting the question very clearly, but what one thing can be done here is like developing the drought monitoring system rather than going into the farm, asking them what is the situation on farm, how they are feeling about that one. I think based on the farmers, like online monitoring system can be developed as a pilot case study where farmers directly can be using some mobile phone, and then that can be fed into the system, and that can be hosted by the some institute or a government related department to monitor the continuous drought situation or impact assessment. The other thing asked is about interventions. I'm not getting it. Sorry.
Actually, he wants to know that after the impact assessment, what are the possible interventions that you would suggest based on the study?
Okay, yeah, so that was the point of discussion. Mostly based on the identified the vulnerability component to a drought situation. Some risk management assessment can be done at local scale, and location-specific mitigation strategies also can be designed for the use of the farmers. That was kept under one slide, policy alternatives to consider, but still, I think it will take too much time to explain here.
Okay.
Mhm.
And we have a second question as well in the chat. It says that it's from Neetu Singh from PhD, and she wants to know that from one of your slides, why the statement is made only for the meteorological drought and why not the hydrological drought has been considered.
Yeah, so that is coming again to the different types of drought which can be visible to farm level. So while doing this, I'm taking one step at a time, not doing everything at in a one go. So the presentation, I showed the scope of this drought research here. That includes most of the things, but here it is mentioned meteorological, agriculture, hydrological drought. But I'm going slow with this meteorological drought. Then recently I'm focusing on agricultural drought, but not on hydrological drought. Although my discipline is integrated river basin management, but I'm not more inclined to hydrological modeling, but this agriculture, water scarcity, and society related issue. So that's why I'm not focusing here hydrological drought. But in future, this kind of like research can be considered.
Okay. Thank you, sir. I think we have a question. Subodh, sir.
Yes, I have two questions. Let me go first. It's not a critique of what your work. It's a general question. Uh, First question is, yes, you collected data, you did some work with GIS and statistical packages, fine. But what is the theoretical base guiding your work? Or it is just, you are trying, you are trying to answer a major, a very relevant, very crucial, practically crucial question. But we are in academics. So uh, what is what is the theoretical frame? What is the theoretical perspective that guide your work on this? I understand that you may not have been able to present it as part of this presentation, but if you can spend some time on that, helping us understand where are you coming from, and that will be helpful. I'll ask my second question later. Let me have.
Okay. Okay, sir. Yeah. So my bachelor's is in agriculture engineering, and then I came for master's in water engineering. So I learned this hydrological cycle and its component in theoretical terms. And then for my PhD also, I wanted to expand that one. But after going to Japan, I started doing some interdisciplinary research, mostly on agriculture, water scarcity, because I belong to that area, and that is also one of the reason why I started doing drought-related research, and one of the farmer in that area also. So while talking about theoretical basis for this, my academic interest is mostly fits to droughts, not as a like whole hydrology component, but mostly about droughts, and then agriculture will also come there, and how this overall is linked to society. These three things I'm focusing in my research. So different tools, every discipline is having different tools and techniques. So to my ability and interest, whatever tool I can use, that I'm using for my drought research, and mostly those tools and techniques are answering the questions related to this overall drought research scope presented here.
Okay, I still didn't get the answer. I believe I was not talking about tools or methods. I was talking about the theoretical framework, because you are trying to combine different disciplines. So how do you see your work getting academic relevance? Because for that you need to have some kind of a theoretical frame, I believe. Possible, if you can talk about it, that will be helpful. Now,
Maybe.
later or tomorrow even you can talk about.
Yes,
I
sir.
don't want
Yes,
to
sir.
take much of your time. But my second question is a very general question. In answering Professor Pennon's question, you uh, said that you got data for the Maharashtra state, and the number of wells is one well per subdivision. I don't know exactly how many subdivisions are there, but not more than 1,000 in Maharashtra, if I believe so. So, I did some work in groundwater, but not this kind of sophisticated work. It's more qualitative work. But at that time, I always used to get, perplexed that how researcher can talk with this kind of sample. It's a minuscule sample, if you agree to me. So,
So
and you build a whole sort of models and systems, etc., on the basis of this data. And that data has two serious problems. The data is very scanty. The
yes,
data collection methods are highly problematic,
yes,
because nobody exactly bothers about how the data is collected, who is collecting data, whether there is an accountability mechanism to ensure that the data is correctly and correctly corrected, authenticized properly, etc., etc. I know about how irrigation department manages its levels. It's a very political thing. If you must be knowing all these things.
yes, yes.
The data about the water in a dam is a very political thing, and it has very emotional, political, all kinds of aspects to it. And you use that kind of data, not you, but researchers, quantitative researchers use all that kind of data, which is highly unreliable in my opinion, to do their research. And I don't find any explanation to do that. I mean, any explanation or any accommodation of this problematic data in their work. How do you look at this?
Yeah, so yeah, thank you for bringing this question here. I think this is also one of the confirmation from your side that we really need to care for the data. Yeah, for my PhD, while based in like Japan, getting data was the most difficult problem. And so at that time, I was as a student trying to get whatever data I can get from the secondary resources. If I go through the proper departmental like request for the data, then it's costing a lot. The cost is other component, which I'm not talking here. But yeah, I have used the whatever data available from the secondary sources, but I failed to evaluate the quality of the data itself. So that is one of the limitations of the most of the studies, maybe ongoing and published also. But if data is manipulated or data is not reliable, still we don't have any choice but go ahead with that proxy indicators or proxy data for that. Yeah.
Okay, thank you.
Thank you, sir. Anyone else? Mm, I think we don't have more questions now.
If there are no further questions, then we can thank Dr. Udmale for his
Yes.
time. And thank you so much for the talk, and then we'll continue our interactions.
Yes, yes. Thank you all for like your patience to listen.